Mike Schultz, Moto Knee and VersaFoot. Context: professional dirt bike and snowmobile racer who lost his leg in a racing accident in 2008. He wanted to return to high-impact competitive racing. The problem was that traditional prosthetics were designed for walking, not extreme sports. When landing jumps, his prosthetic legs shattered because they could not absorb high-impact forces. Therefore, he designed performance prosthetics with built-in shock absorption inspired by dirt bike suspension systems. The Moto Knee and VersaFoot could withstand these intense impact and stress. The effect was that he returned to elite competition and won medals. His designs were adopted by other adaptive athletes and raised the performance standards in adaptive sports. Jack Burton Carpenter, snowboarding. The context was that he loved surfing and snow sports during a time when snowboarding was not recognized as a legitimate sport. The existing Snurfer was considered a toy. The Snurfer lacked stability, control, and durability. Ski resorts banned snowboarders, and the sport lacked legitimacy. The innovation was that he built longer, wider, and more flexible boards with bindings for better control. He also promoted snowboarding, organized competitions, and worked to gain acceptance at ski resorts. The effect was that snowboarding became widely accepted and eventually an Olympic sport. His company, Burton, became a global leader, and his innovations shaped the modern snowboard industry. The pattern across the both stories. Neither innovator began with formal engineering or design training. Both were deeply involved in the sport they were trying to improve. Both began innovating in response to limitations they personally experienced. Early solutions were rough, iterative, and shaped by trial and error. The innovation only mattered once it extended beyond the individual. Schultz's designs were adopted by other athletes, and Carpenter's equipment innovations succeeded only when others used them and institutions allowed their use. Ariel Rosen, the Rosen Glove. Wheelchair racers experienced discomfort and fatigue during competitions. She had access to 3D printing technology but no formal engineering training. The problem was that existing racing gloves were heavy, inefficient, and caused significant arm and hand fatigue. The innovation was that they designed lightweight, molded plastic gloves using 3D printing. They were as durable as traditional pellet gloves, but half the weight, improving both comfort and performance. The effect was that it reduced fatigue for athletes and improved wheelchair racing efficiency. Her gloves were adopted by teammates and eventually used at the Paralympic level, expanding access to better adaptive equipment. Chris Yu and Mark Coate, Wind Tunnel. The context was that engineers with a passion for elite cycling who recognized the importance of aerodynamics and performance. Wind tunnel testing was expensive and inaccessible, limiting their ability to test bikes and equipment for aerodynamic efficiency. The innovation was that they built their own wind tunnel within 17 months, allowing them to test and refine bikes, helmets, shoes, and other cycling gear. The effect was accelerated innovation in cycling equipment and created a comprehensive aerodynamic testing ecosystem. Their work improved elite athletic performance and influenced broader cycling design practices. The pattern across both these stories. Innovation begins with unmet needs or limitations. Access to tools, spaces, or infrastructure matter. Collaboration and learning from others are central, and innovations often extend beyond the original problem and create wider impact. Robert Hubbard and James Downing, Hans device. They observed that basal skull fractures were a leading cause of death in motorsport crashes. The body was restrained by seatbelts, but the head moved violently during impact. Severe head and neck injuries were common and often fatal in high-speed crashes. The innovation was that they developed the head and neck support system, Hans device, which connects the helmet to the body restraint system to limit head movement during collision. The effect was that initially resisted by drivers, adoption increased after high-profile fatalities. The device became mandatory in major racing organizations and has saved hundreds of lives, fundamentally improving motorsport safety. Robert Cade, Gatorade. The University of Florida football players were losing significant weight during practice and suffering from dehydration. Multiple players had been hospitalized. The problem was that athletes were losing fluids and electrolytes faster than water alone could replace them, harming performance and health. The innovation was that they conducted research analyzing blood and urine samples before and after practice. They developed a drink containing water, electrolytes, and glucose to restore what athletes lost through sweat. The effect was that despite early resistance due to taste and perceptions of weakness, performance improved dramatically. Gatorade became widely adopted, creating the sports industry and changed hydration practices across athletics worldwide. The pattern across both these stories is that innovation followed careful problem analysis rather than quick fixes. Early resistance was common despite the clear benefits. Adoption accelerated after performance gains or tragic events, and innovations extended beyond their original context and use. Art Arat, breakaway rim. As dunking became more popular in basketball, traditional rigid rims and backboards frequently broke. Existing equipment could not withstand the increased force from dunking, leading to safety risks and equipment damage. The innovation was that they designed a spring-loaded flexible rim that bends under pressure and snaps back into place. This made dunking safer and more sustainable, preserved equipment, and permanently changed the style and evolution of modern basketball. Hinda Miller, Elisa Lindell, and Polly Palmer Smith, the jog bra. During the 1970s running boom, more women began participating in long-distance running, but lacked the appropriate athletic support garments. Traditional bras were uncomfortable and inadequate for high-impact athletic activity. Inspired by the structure of a jockstrap, they created a compression-based sports bra without hooks or clasps, designed specifically for athletic movements. Despite early resistance from sporting good retailers, the product gained popularity and led to the development of the sports bra industry. It significantly expanded comfort, access, and participation for women in sports. The pattern across both these stories is that innovation followed shifts in performance or participation. Historical conditions shaped when innovation became necessary. Serendipitous insight reframed existing problems. Material advances enabled new solutions, and adoption eventually reshaped the activity itself.